What if Einstein's greatest theory had a fatal flaw hole so big it could rewrite the universe as you know it? Don't miss this, because 99% of people have no clue what's coming. You've probably heard Albert Einstein was a genius, right? His theory of general relativity, published in 1915, changed how you and I understand space, time, and gravity. It's the foundation of modern physics, powering your GPS, explaining black holes, even inspiring your favorite sci-fi movies. But here's the problem. There is a gap in relativity so baffling that even Einstein couldn't fully explain it. It's a cosmic mystery that's been hiding from you your entire life. Why should you care? This flaw challenges everything you thought you knew about the universe. It's like building your dream house on a shaky foundation, one crack, and it all risks collapsing. Have you ever wondered why the universe doesn't always follow the rules you learned in school? For instance, why does a photon of light lose energy as it travels through space? Or why does a rock you throw in deep space eventually slow down and stop? You were taught that energy is always conserved. Newton's laws, energy in equals energy out. It's a comforting idea, like a universal promise that everything stays balanced. But in Einstein's universe, that's a myth. Energy can vanish into thin air, and even the greatest mind of the 20th century couldn't fully explain why. This isn't just a puzzle for scientists, it's a question that shakes how you see reality itself. Here's where it gets frustrating. Scientists spend years trying to force energy conservation into relativity, twisting math to make it fit. They wanted the universe to be neat and tidy, but the universe doesn't care about your comfort zone. This gap in relativity stumped even the brightest minds, like Einstein and his colleague David Hilbert, a legendary mathematician. They were desperate to solve it, but the answer eluded them. So, what's at stake for you? If energy isn't conserved, what happens to the rules that govern your world? What does it mean for the physics that powers your life? You might be thinking, I'm no physicist, why does this matter to me? Stick with me, because this story isn't just about equations. It's about a woman who turned cosmic confusion into clarity, and her discovery will blow your mind. But here's the twist. The solution came from someone you've likely never heard of, a mathematician who fought against all odds to change how you see the universe. Ready to meet her? Enter Emmy Noether, a mathematical genius who reshaped physics yet history nearly forgot her. Born in 1882 in Erlangen, Germany, Noether grew up in a family of scholars. Her father was a mathematics professor, but as a woman, she was denied formal university admission. Undeterred, she audited classes, earned her doctorate in 1907, one of the first women in Germany to do so, and became a trailblazer in mathematics. Despite her brilliance, she faced constant barriers, only securing a teaching position with the support of David Hilbert, who famously defended her by saying, "I do not see that the sex of the candidate is an argument against her admission. After all, we are a university, not a bathhouse." In 1915, while Einstein struggled with his general theory of relativity at the University of Göttingen, Noether was Hilbert's assistant. She wasn't just crunching numbers, she was unraveling a cosmic puzzle that would redefine physics. Let us break down her revolutionary discovery in 3 simple steps, a blueprint that unlocks the hole in relativity. Step 1. Discover the power of symmetry. Noether realized the universe operates like a perfectly choreographed dance, governed by symmetry. Imagine throwing a ball, it behaves the same whether you're here or a mile away. That's translational symmetry. Spin a top, and it doesn't care which direction it's facing. That's rotational symmetry. Do an experiment today or tomorrow, and the results stay the same. That's time symmetry. Ever notice some things feel constant no matter where you are? That's symmetry at work. Here's the game changer. Noether discovered that every symmetry hides a secret, a conservation law. It's like finding the universe's hidden rulebook, and it's about to blow your mind. Step 2. Connect symmetries to conservation laws. Noether's first theorem is like a cosmic map. Every symmetry corresponds to something conserved. Translational symmetry gives you conservation of momentum. Rotational symmetry. That's conservation of angular momentum. Time symmetry. That's where conservation of energy comes from. It's as if she cracked the code to the universe's deepest secrets. But here's the shocking truth. Our universe isn't perfectly symmetric. It's expanding, stretching like a cosmic rubber sheet. Over billions of years, time symmetry breaks down. That's why a photon from the Big Bang loses 99.9% of its energy, shifting from visible light to microwaves. That's why your rock in space slows to a stop. Energy isn't conserved in an expanding universe, and Noether showed us why. This was a revelation. Einstein assumed energy had to be conserved, but Noether proved it only holds in small, local patches of space-time. On a cosmic scale, the rules are different. Step 3. Embrace the local universe. Noether's second theorem takes things to another level. In general relativity, space-time is curved, like a warped trampoline. You can't shift the entire universe and expect everything to stay the same. Instead, Noether found local symmetries rules that hold in tiny regions of space-time. Picture these regions as pipes carrying energy. Within each pipe, energy is conserved, but between them, the curvature lets energy leak out. This is the hole Einstein didn't predict. Energy can vanish into the fabric of space-time itself. Noether's continuity equation, a mathematical masterpiece, shows how energy flows locally, but not globally. It's like water moving through cracked pipes. Some escapes, and that's perfectly fine. Her equation aligned with Hilbert's Bianchi identities, proving they were the best solution possible. Here's the mind-blowing part. Noether didn't just fix Einstein's issue. She gave you a new lens to view the universe, one that powers everything from black hole research to the discovery of the Higgs boson. But here's where most people miss it. Noether's breakthrough wasn't just about math. It was about defying impossible odds to change the world. Ready to see how her story can transform your perspective? Picture this, it's 1915, and you're Emmy Noether. You're a woman in a male-dominated field, barred from formal education because of your gender. The academic senate claims your presence would overthrow all academic order. Yet, you persist, auditing classes, earning your doctorate, and teaching in secret. When the Nazis banned Jewish scholars like you from universities in 1933, you continued holding seminars in your kitchen, even welcoming a student in a Nazi uniform because your passion for math knew no prejudice. You fled to America, teaching at Bryn Mawr College until your death in 1935, leaving a legacy that reshaped physics. That's the transformation Noether achieved, and it's a lesson for you. Before her theorems, physicists were trapped, trying to force old ideas into a universe that didn't fit. After her work, they saw the world through symmetries. Suddenly, you could predict new particles, explain fundamental forces, even understand why mass exists. Her ideas made discoveries like quarks and the Higgs boson possible, and they're why your GPS pinpoints your location today. Here's a real-world example. In the 1960s, physicists used Noether's principles to discover the Higgs boson, the particle that gives everything mass. Without her, we'd still be lost in the dark. Her theorems are like a master key, unlocking doors to a universe you never imagined. So, what does this mean for you? Noether's story proves the universe isn't just about equations, it's about resilience, curiosity, and breaking barriers. Maybe you're facing your own challenges, feeling like the world's stacked against you. Noether's life whispers, keep asking questions, keep experimenting, and you can change your world, too. Think of it this way, every time you learn something new, you're walking in Noether's footsteps. Start with the basics, like she did, and soon you're asking big questions, sparking discoveries. Maybe you'll inspire the next breakthrough, just like my kids did when they tinkered with a Cowico disc launcher, adjusting angles to make it soar farther. Here is your challenge. Take one thing from this video, whether it's Noether's theorems or her unstoppable spirit, and let it ignite your curiosity. Comment symmetry below if you're ready to explore the universe in a new way. Don't miss our next video, diving deeper into how Noether's ideas fueled the quantum world. Hit that subscribe button and bell icon so you don't miss it. Thanks for watching, and I'll see you in the next one.